Hi all, welcome to Learn Easy channel. Today's topic is hybridization. In this video, we're going to see what is hybridization, what are the different types of hybridization, and how to draw the shape of different molecules. First, we'll see what is hybridization. Hybridization is the mixing of two atomic orbitals to give rise to a new type of hybridized orbitals. For example, s orbital and p orbital mix up to form sp hybrid orbital. The new hybrid orbital will have different energy. The atomic orbitals of same energy levels mainly take part in hybridization. Okay, next we will see the types of hybridization. sp, sp2, sp3, sp3d, sp3d2 and sp3d3 are the types of hybridization. Next we will see the representation of hybrid orbitals. When s orbital mix up with p orbital, it forms a sp hybrid orbital. S orbital is spherical in shape and p orbital we know it is dumbbell in shape. So when these two mix up, it overlaps to form a shape like this, like dumbbell shape. Over that a spherical shape is there. So we can represent this sp hybrid orbital like this, like a half dumbbell shape with a small loop. We can represent like this, or we can represent just half dumbbell shape. We can represent a hybridized orbital like this. Now we will see the first type of hybridization, that is sp hybridization. Example for such hybridization is BeCl2, that is beryllium chloride. Atomic number of beryllium is 4, so we can write the electronic configuration as 1s2, 2s2. In ground state there will be 2 electrons in s orbital. In excited state, 1 electron from s orbital will jump to p orbital. So there will be 2 half-filled electrons in the case of beryllium. Now we'll see for chlorine. Chlorine there will be 5 valence electron. 5 valence electron in 3p orbital. So 1, 2, 3, 4 and 5, there will be 1 half-filled electron in one chlorine atom. Since there are 2 chlorine atoms, 2 half-filled electrons will be there. These two will overlap with s and p orbital from beryllium and it forms a linear shape. Okay, the structure for beryllium is a dumbbell shape, and it since chlorine in chlorine atom it overlaps with the p orbital, so we have to draw a dumbbell shape here for one chlorine atom and one more dumbbell shape here for another chlorine atom. So it forms a linear shape and the angle is 180 degree. Next we will see sp2 hybridization. Example for sp2 hybridization is BeCl3. In boron, atomic number is 5, so 1s2, 2s2 and 2p1. In ground state, there will be 2 electrons in 2s orbital and 1 electron in 2p orbital. In excited state, 1 electron from s orbital will jump to 2p orbital. So there will be 3 half-filled orbitals. These two s and p orbital together they form sp2 hybrid orbital. This is sp2 hybrid orbital. Now what happens in chlorine, there will be 5 electrons in 3p orbital. So 5 electrons in 3p orbital, it needs 1 electron for each chlorine atom. So these three electrons will pair up with these 3 electrons in chlorine atom, and it forms an hybridization, sp2 hybridization. So how to draw the structure of BeCl3? See, for boron, sp2, since it is a 3 sp2 hybrid orbital, so we have to draw 3 shapes like this. This is for boron. Okay, and for chlorine atom, since the hybridization takes place in p orbital, we have to draw a dumbbell shape for each chlorine atom. So for 3 chlorine atom, we have to draw 3 dumbbell shapes over the boron. So it forms a trigonal planar shape. The angle will be 120 degrees. Next we are going to see About sp3 hybridization. Example for sp3 hybridization is CH4. For carbon, the atomic number is 6. So the electronic configuration is 1s2, 2s2, 2p2. In ground state, there will be 2 electrons in 2s orbital and 2 electrons in 2p orbital. So in excited state, the 1 electron from 2s orbital will be shifted to 2p orbital. So totally there will be 4 unpaired electrons. This s orbital and p orbital together mix to form sp3 hybrid orbitals. These 4 unpaired electrons pair up with 4 unpaired electrons of hydrogen to form sp3 hybridization. The shape of CH4 molecule is tetrahedral, and the angle is 109.5 degrees. Now we are going to see how to draw the structure of CH4. Since it forms sp3 hybridization, so we have to draw for carbon four shapes like this, 4 hybrid orbitals, and it overlaps with 4 s orbital of hydrogen. So we have to draw spherical shapes, 4 spherical shapes, since s orbital is spherical in shape. So we have to draw 4 spherical shapes which overlaps with the sp orbital of carbon. Next we are going to see sp3d hybridization. Example is PCl5. Phosphorus having atomic number 15 has an electronic configuration 1s2, 2s2, 2p6, 3s2 and 3p3. The ground state, in ground state there will be 2 electrons in 3s orbital and 3 electrons will be there in 3p orbital. In excited state, 1 electron from 3s orbital jumps to 3d orbital and it forms sp3d hybrid orbitals. So there will be 5 unpaired electrons in phosphorus. When you take chlorine, each chlorine atom will have 1 unpaired electron. So totally there will be 5 chlorine atoms. So there will be 5 unpaired electrons. These 5 unpaired electrons from phosphorus will pair up with 5 unpaired electrons of chlorine and forms sp3d hybridization. The shape of PCl5 will be trigonal bipyramidal shape. Here these 3 chlorine atoms will be in a single plane and 1 chlorine will be in the front and another chlorine will be at the back, and it forms a pyramidal shape. Since there are 2 chlorine atoms, it forms 2 pyramidal shapes, so trigonal bipyramidal shape. Next we are going to see sp3d2 hybridization. Example of sp3d2 hybridization is SF6. For atomic number of sulfur is 16. So it has an electronic configuration 1s2, 2s2, 2p6, 3s2, 3p4. In ground state there will be 2 electrons in 3s orbital and 4 electrons in 3p orbital. During the excited state, 1 electron from 3s orbital will jumps to 3d orbital and 1 electron from 3p will jumps to 3d orbital. So in excited state there will be 1 electron in 3s orbital and 3 electrons in 3p orbital and 2 electrons in 3d orbital. So it forms sp3d2 hybrid orbitals. These unpaired electrons in sulfur will pair up with unpaired electrons of fluorine. Fluorine has an atomic number 9, so the electronic configuration is 1s2, 2s2, 2p5. So it has 1 unpaired electron for each fluorine atom. So totally 6 unpaired electrons because there are 6 fluorine atoms. So these 6 unpaired electrons of sulfur will pair up with 6 unpaired electrons of fluorine and forms sp3d2 hybridization. The shape of SF6 will be octahedral in shape. Next we will see sp3d3 hybridization. Example is IF7. Atomic number of iodine is 53. So it has an electronic configuration like this, And let me see the valence electron. It has 5s2, 5p5. So in ground state, there will be 2 electrons in 5s and 5 electrons in 5p orbital. In excited state, 1 electron from 5s will shifts to 5d orbital and 2 electrons from 5p shifts to 5d orbital, and it forms sp3d3 hybrid orbitals. There are 7 unpaired electrons in iodine. These 7 unpaired electrons will pair up with 7 fluorine atoms, and it forms sp3d3 hybridization. Electronic configuration of fluorine is 1s2, 2s2, 2p5. It has 1 unpaired electron in 2p orbital. There are 7 fluorine atoms, so totally 7 unpaired electrons. So 7 unpaired electrons from iodine pairs up with 7 unpaired electrons of fluorine to form sp3d3 hybridization. The shape of IF7 is pentagonal bipyramidal. Like this 5 fluorine atoms forms in pentagonal in a single plane, and 1 fluorine at the back and 1 fluorine at the front forms in pyramidal shape, so it is pentagonal bipyramidal shape.